Good morning. Today we start the new chapter is transportation problem. That is we have learned in this chapter that is way to solve transportation problem, some important definition, loop in transportation table and their properties, optimality test, degeneracy in transportation problem, unbalanced transportation problem and numerical example. That is, first we have seen the basic definition of transportation problem. That is, the transportation problem is a particular class of linear programming problem and occurs more frequently in practical life. In general, the transportation is concerned with the distribution of a certain product from several sources to location at minimum cost. That is, company want to the goods transport from the source to destination, and we want to the total transportation cost is minimum. That is called the transportation problem. Suppose the non-negativity quantities A1, A2, AN and AM of the product are available at M place, and other called origin or source, and the non-negativity quantities B1, B2, Bj up to Bn of the same product are required at the other N place called the destination. Assume that the total available is summation of AI is equal to the total requirement, that is summation of Bj. Further, suppose that Cij the cost of transportation of a unit quantity from the I origin to j destination. Then the problem is to determine Xij, the quantity which is to be transported from the I to origin j destination in such a way that the total transportation cost is minimum, and mathematically a transportation problem may be put in the form of the table. That is this the tabular form of the transportation problem and tabular matrix of the cost matrix of the transportation problem. That is d1 d2 dj up to dn is the destination, and o1 o2 oj and o up to om is the origin. That is we want to the goods transport from this destination, this origin to destination, and this the transportation cost, that is C1 1, C1 2, C1j up to C1n, C21, C22, C2j up to C2n, up to CI1, CI2, CIJ, CIN, up to CM1, CM2, CMJ, and CMN is the transportation cost. And this the available quantity is A1, A2 up to AJ up to AM, and requirement is Bj, that is B1, B2, Bj up to Bn, and here total availability equal to total requirement. That is problem is balanced transportation problem. That is summation AI equal to summation of Bj. That is Cij is the transportation cost Tc of the unit quantity from ith origin to j destination, and let Xij be the quantity to be transported from I origin to j destination, and total transportation cost is minimum equal to z equal to summation of Cij into Xij, and such that that is xi1 plus xi2 plus up to plus xij plus up to xin equal to a1, and xij plus x2j plus up to plus xij plus up to xmj equal to bj, and I equal to 1 to up to m, and j equal to 1 to up to n, and non-negativity constant is xij is greater than equal to 0, and we seen the basic definition of transportation problem that is we seen the basic definition of transportation problem that is feasible solution, objective function, unbalanced transportation problem, and others some definition we have seen and we have learned in this chapter. That is, we have learned the terminology used in transportation model, that is feasible solution, non-negative value of xij where I equal to 1 to up to m and j equal to 1 to up to n, which satisfies the constraint of supply and demand is called feasible solution. And basic feasible solution if the number of positive allocation are m plus n minus 1. An optimal solution is feasible solution is said to be optimal if it minimizes the total transportation cost. And balanced transportation problem is, that is transportation problem in which the total supply from all sources is equal to the total demand in all destination. And unbalanced problem which are not balanced are called unbalanced, that is there is no total supply equal to, that is total demand, is the unbalanced transportation problem. And matrix terminology, in the matrix the square are called cells and form the column vertically and row horizontally, it is matrix terminology. And degenerate basic feasible solution if the number of allocation in basic feasible solution is less than m plus minus 1. And optimal solution of the transportation problem, that is first step is find the initial basic feasible solution, and step second obtain the optimal solution by making successive improvement in initial basic feasible solution until number further decrease in transportation cost is possible. And there is finding the method of initial basic feasible solution, that is northwest corner method, lowest cost entry method, Vogel approximation. And we seen the unbalanced transportation problem, that is demand is less supply, that is in this condition demand is less than supply, then add dummy column in matrix with 0 cost, and supply less than demand, then add dummy row in the matrix with 0.